Hi there, I'm still Ms. Lee. We're going to talk about solving differential equations. So there's two types that we're going to do. The first one is going to be finding the general solution. The second type is going to be finding the particular solution. So I'll be doing two examples in this video. Okay, so find the general solution for dy dx equals x plus 1 squared over y. So when you're looking at this, this is in fact a differential equation because it has dy dx in it. And then when it says find the general solution, when you read that, what you should be hearing is that means include plus c in your answer. Okay, so you can have a c in your answer is basically what this is saying. Okay, so when you're trying to solve this differential equation, the basic step is to separate the variables. So we do this by starting by multiplying by dx. In general, you should only be multiplying and dividing by things. There should be no adding and subtracting. So you want to multiply by dx, and dx and dy are, in fact, x in terms of x and y. So dy is y, and dx is in terms of x, of course. And so when you multiply by dx, you have dy equals x plus 1 squared over y times dx. And so what you want to do is get the y to the other side. You want all x's on one side and all y's on the other side. That's what it means to separate the variables. So I'm going to multiply the y to the other side, and so I have y dy equals x plus 1 squared dx. Okay. And so when you're looking at this, you should see that there are only y's on the left side of the equation, and there are only x's on the right side of the equation. Therefore, the variables are indeed separated, and so we'll move on to the next step, which is to integrate both sides. Integrate both sides. Okay, and when you're integrating both sides, you're going to want to put a plus c on one side. You do not need to put it on both sides, just one side. Okay, so we'll integrate this side. The integral of y is, we would use the power rule. And so since this is y to the 1 power, we would do y to the 2 power over 2, so y squared over 2 equals, and then over here you kind of got to use u substitution. You can do u substitution in your head if you would like. So basically it's going to be the entire x plus 1, and then you like cube it over 3. But for those of us who are not as familiar, we'll go ahead and write out the u substitution. So you have u equals x plus 1, du equals dx. And then we substitute all that in, and when you substitute all that in, you have u squared du. And you can just integrate that easily. So it'll be u cubed over 3, but u is just x plus 1. So we have x plus 1 cubed over 3. And then we're going to put plus c on this side. So like I said before, maybe we should write this down. Okay, so don't forget to include the plus c, but also just include it only on one side. Okay, so just one side. Okay, and there we have our general solution because we have a plus c. So this is it, unless the question asks you to solve for y. In this question, we were not asked to solve for y. It just says find the general solution. This is the general solution. And so there we have it. This is the general solution. There's a plus c, and that's your answer to the problem. So let's try a different example. In this example, we're going to find the particular solution. Okay, so it says find the particular solution for the differential equation dy dx equals y sine of x and given y of 0 equals 6. Okay, so there's a couple of things here that I want you to know. In the words particular solution, when you read that, I want you to think in your head, okay, particular means that you want to find like the specific one. So basically, you need to solve for C. Solve for C. Okay, so you still need to do the plus C, but ultimately you want to solve for C and get an actual value for C. And then it says, given y of 0 equals 6, we call this the initial condition. Initial condition. So anytime it asks you for a particular solution, there is an initial condition somewhere in the problem that you need to solve for. Okay, so let's go ahead and give this a try. So same as for general solution, we're going to go ahead and separate the variables. So we start by separating the variables. And we're going to multiply by dx first. So if you multiply by dx, what you get is dy equals y times sine of x times dx. So times dx is on the other side. You'll notice that there is a y here that is on the x side. So we need to get rid of that. And as you know, we should only be multiplying and dividing. And so you're going to go ahead and divide that y to the other side. So we have dy divided by y equals sine of x dx. And just as before, we're going to integrate both sides. And as you know, the integral of dy over y, or the integral of 1 over y, is ln of absolute value of y. And then the integral of sine of x is negative cosine of x plus c. So because we were given an initial condition, we're not done. If it had asked for the general solution, we would be done because we have some equation equals and then with a plus c in it. But since it gave an initial condition, we need to plug in the initial condition to solve for c. So we'll plug in y of 0 equals 6. That means you plug 0 in for x and 6 for y. So we have ln of 6, or absolute value of 6, equals negative cosine of 0 plus c. So cosine of 0 is 1. And if you're not sure about what it is, you can just leave it as cosine of 0. You will not be docked points for not knowing your trig functions. And then you get c equals ln of 6, and then plus cosine of 0. And so solving for C isn't your final answer. Your final answer is going to be your equation with C plugged in. So plug in C. And so your final answer would be ln of absolute value of y equals negative cosine of x plus ln of 6 plus cosine of 0. So of course, if you were to simplify this a little bit, you could get ln of absolute value of y equals negative cosine of x plus 1 plus ln of 6, because cosine of 0 is 1, but it doesn't matter, either one of these work. You have now found the particular solution because you found your equation and you solved for C and plugged it back in. So there you have it. That's how you solve differential equations, whether you are given an initial condition and you find the particular solution, or if you're not given the initial condition and you find the general solution. Happy day!